BiPC&MPC.com.
Okay, students, after completion of the more theory sessions, and we are here to finally on question session. Okay, here we are going to discuss the various models on the, especially we will focus on the very difficult topic and very tough topic, that is hydrogen spectrum. Okay, I will be covering all concept, but focusing will be on the hydrogen spectrum, and all questions I am going to discuss in this lecture will be different model, either they are previous questions or based on the previous question, the questions which will come into your examination. Okay, so from the previous questions you will be able to understand what type of questions will be there, what will be the level, and you can manage yourself according to the pattern of the questions. Okay, so that's why this question session is very important, and all of you should be available with pen and paper, start noting down, and I will give you a pause, I will give you a time so that you yourself can try. If it is correct or not, then go through my video explanation. Then you will come to know that whether your answer is correct or not. If correct also, then you should cross check whether any short cut procedure or any other points related to any other question related to that came. Okay, so various information will be conveyed during the explanation also. So explanation also important, and question model also important. So only thing, you should not lose your enthusiasm. If one question is wrong, don't worry. If question is correct, don't stop it there itself. Okay, so because all models are different, no model is repeated. Okay, if suppose today I will be covering 8 questions, so 8 questions will be different only. Okay, something you will find difference. So I don't think any other model will be there in future also. Okay, so that is the advantage of question session. Okay, now here the very first question I'm going to write, and the hydrogen spectrum. In hydrogen spectrum, a series limit okay, a series limit found to be at 12186.3 centimeter inverse. Okay, then it belongs to okay, so series name you should write. First option they have given as Lyman series. What they have given as Lyman series. Okay, second is Balmer series. You can expect by the time I have written the question, so if you feel that you can start and cross check with your options. Okay, then Paschen series, and fourth option is bracket series. What is the fourth option? Bracket series. Okay, so these are the 4 options given. Now here what is given? Limit, series limit. The main question word is limit. Okay, all of you, if you have gone through thoroughly the hydrogen spectrum's theory lecture, then I have specially mentioned about this word. Okay, limiting line, limit line. Okay, what you have value you have to take, and it is found to be at the centimeter inverse. What is the units? That is wave number is given. What is given? Wave number is given in terms of centimeter. Units also important. Units like centimeter inverse. With this I could come to know that wave number. Okay, that it belongs to which series. Now you can give it a try. Okay, okay, tried, not able to do, then I will give you a hint. Okay, here limit means limiting line. Whenever there is a limiting line means last line. Who will come last? Who is coming from the largest distance? Who is coming from the infinity? That is n2 is equal to infinity. This word is giving us a hint that use n2 is equal to infinity. In hydrogen spectrum, Z is equal to 1. Belongs to series name you have to tell. That means n1 you have to find out. That is the question. Okay. So you now you can try it. So I will tell you 1 upon lambda. That is mu bar is already given. Mu bar is equal to RH into 1 upon n1 square minus 1 upon n2 square into infinite, sorry, into z square. Okay. So here what, this is what you find out. N1 you will find out. RH value I told you with the trick also. Okay. 109678, and remember that they are in centimeter inverse because this is very much important. Centimeter inverse. So Z is equal to 1, N2 is equal to infinity. Lambda is equal to how much? 1 to 186.3. Okay. So I will write it here clearly so that whatever the values have given, and then I will find out the solution. Okay. See, new bar 1218.6.3. Units are must be same. Centimeter is equal to 109678 centimeter inverse, and rest all are unitless. 1 upon n1 only we don't know. 1 upon infinity square into z square, that is 1 square. Okay. So simply this all will be eliminated. So n1 square is equal to 109678 divided by 12186.3. Okay, n1 square this will be. So on simplification, you are getting approximately you'll get 9. So n1 is equal to 3. So this n1 is equal to Lyman is 1, Balmer is 2, and Paschen series is 3. So n1 3 means Paschen series. Answer is what? Paschen series. C option is correct. Okay. First question, is it understood? Likewise, detailed explanation will be given and different model will be covered. So will you stay with me? Okay. Okay, next wonderful question. Very, very interesting question. Very, very difficult question. Very, very technical question. Okay. So typical question. If you handle it in a technical way, you will get answer. Otherwise, you will not get answer. Okay. So most others, what they will do, option verification. A simple word they will use, option verification. But it is going to take your more time. Okay. So I know the cost of the time in the examination. 1 hour you have to solve more questions. Okay. So that cost should be reduced. Understood? So, but you can give a try. Okay. I will explain the question. Which transition in hydrogen atomic spectrum? That means we wanted to find out what is N1, what is N2. Okay. Of hydrogen which will have same wavelength. That means the wavelength of light emitted must be equal to the transition of helium. N1 is equal to 2 and N2 is equal to 4 of the helium plus. Okay. So when this transition is made, whatever the wavelength produced, similar wavelength will be produced for what? N1 and N2. Okay. Question, is it understood? I think that lot of English is there and it is made simple. Okay. So N1 and N2 both you have to find out, and you are given with only one hint. This much will be what equal. Understood? You give a try. If you're done means you are really genius. Okay. Until unless you are not done it earlier. Okay. Done. Let's see. So simply whatever given, I will write it here. Okay. 1 upon lambda is equal to 1 upon RH. I will write it. Okay. RH into 1 upon n1 square minus 1 upon n2 square into z square. Here z is equal to 1. Okay. So this must be same here also. RH of 1 upon here 2 square minus 1 upon 4 square into how much square? 2 square. So this is given, this n1 and n2 you have to complete. Is it understood? Now the technique is just send this 2 inside. Okay. Now this RH is equal to, when I send this inside 2 square will get cancelled. So 1 square will be left over. And 1 2 square will be get cancelled, 2 square will be left over. Okay. So here see everything appear to be same. 1 upon n1 square minus 1 upon n2 square. Okay. This and this get cancelled. N1 place 1, N2 place 2. So 2 to 1. What is the answer? D option, 2 to 1. No option verification, no large calculations. Simple technique. Send 2 square inside and you will get answer by comparing the two terms. Okay. Do you understand now? Good. Okay, next question is, in Bohr series of lines of hydrogen spectrum, the third line from the red end. This is the main keyword. While studying itself, what is the glitch in the question you should able to understand. Corresponding to which one of the following inter-orbit jump of the electron from Bohr orbit in an atom of hydrogen. Okay, so third line from red end. This trick already I given you in my theory lecture. So if you are not attended or not fully attended, not knowing, just go to the playlist, select atomic structure, select hydrogen spectrum theory, then you will go through it. Understood? So very simple, playlist, atomic structure, hydrogen spectrum. Okay, theory. And that was a theory session where I mentioned, and application part also you should know. Only theory will not work and only question you will not be able to solve. Understood? Even though you solve, it may be difficult. When you go through the theory and solve, it will be easy. Okay. From red end, that means it is a visible. What it is? Visible. So visible is region. From the region, what we can find out? N1 value. Lyman is ultraviolet. Balmer is visible. So N1 is equal to 2. And third line. Okay, so already I told you first line is called alpha line, second line is called beta line, and third line will be called as a gamma line. Okay, so n2 will be n1 plus 3. So as it is 2, so 2 plus 3 it is equal to 5. So 5 and 2, where it is there? From 5 to 2, hydrogen spectrum. Okay, 5 to 2. From 5 to 2. Is it understood? Any doubt about this? Okay. And how you will come to know 5 to 2 or 2 to 5? Simple. It is a emission spectrum. Hydrogen spectrum is a emission spectrum. So higher to lower. That also I mentioned in the lecture. Higher to lower emission, lower to higher absorption. Hydrogen spectrum is formed by the emission lines only. Okay. Okay, there is one more another logical question. Okay, all these are selected for you people only. Understood? Which electronic level would allow the hydrogen atom to absorb photon but not emit a photon? It should be able to absorb only. It should not able to give. Okay. So for that, this is just a theory-based question. Understood? So suppose electron is here. Okay. From here to here, it will absorb. Okay. But if it want to go here to here, it will be emitting. Okay. When it jumps from higher to lower, it will emit. When it jumps from lower to higher, it will absorb. So what he want? Only absorb. It should not emit. It should not emit means it should be at the already lowest possible position. Which is the lowest? So it cannot go inside, because inside there is a dangerous nucleus. Understood? Nucleus, once it catches electron, it will become a big zero because nucleus have proton. Proton plus electron, zero. So electron available at this will never wanted to go to the dangerous nucleus. So what it will do? It will always go away from each, and that will absorb only. It will not emit. Understood? So the answer should be first energy level. Here third energy level, second energy level, second energy level, first energy level. So answer is D option. Is it understood? Why second option? Sorry, why D option? That you don't worry about all these, all to just to give a tough look, complicated look only. Answer is there in the number itself. Understood? So complication increased by adding SPDF. All these are all. Answer is not there. Answer is in the number only. Okay? Understood? Ready for next question? Good. Okay, next question. The energy required to break 1 mole of Cl bonds in Cl2 is 242 kilojoule per mole. The largest wavelength of light capable of breaking single CCl bond is. Wavelength you have to find out, bond energy given. Okay. Can you do it? Give a try, then check with my answer. You are smart or me? If you are able to do it better than me in shortest steps, then take a bow. Okay. Okay, tried. Now let me do it better than, faster than you. Okay. See, here the glitch is 242 kilojoule. You are seeing here only. I will see it here. 1 mole of bond this much, but question is single chlorine bond. Okay, so 242 into 10 to the power of 3. Now it will be joule. These are for 1 mole, but I want energy for single molecule. So 6.02. Whatever the value he have given, that only I know it is 023, but I will not use because he has given. Okay. If we give the 25, then I will write 25 only. Even though it is wrong, I will substitute that only. While attempting the exam, question paper is everything. Understood? If print mistake is there, you will go as per the print mistake values only, because after that you can authorize. Sir, it is given. That's why I substituted. Understood? So this is energy per bond. Okay. So directly what I will do, I will E, this is E. Now my intention is to find out what wavelength. So that Hc upon lambda is equal to what? Hc upon lambda. Okay. Now I think you already know the H value. Okay. So this should I erase it? This question I have noted everything required for me. Then I will erase this. Okay. Now 242 into 10 to the power of 3 divided by 6.02 into 10 to the power of 23 is equal to 6.626 into 10 to the power of minus 34 or 34 into 3 into 10 to the power of 8. Like this doubts I will also get, and you should also get. Okay. If you don't get now, then you will get doubt in examination also. 6.626 into 10 to the power of minus 34 or plus 34. Think and refer. Okay. Got it? You might be saying, what, sir? You are confusing us, sir. This confusion should be here, not in exam. Okay. If you are confused and confirmed now, then you will not confuse in the examination. So lambda is equal to 6.626 into 10 to the power of minus 34 into 3 into 10 to the power of 8 divided by, sorry, this also will be into only 6.02 into 10 to the power of 23. Okay, divided by 242 into 10 to the power of 3. Okay, I have solved on my own. So I got 494.7 something. Okay. So nearby option is this one. So D option is correct. Okay. And they are in nanometer. Which meter? nanometer. Okay, is it understood? Shall we proceed with the next beautiful question? Are you ready for that? Okay, at least now you improved your level. Let's see if you are able to do this. That means there is some improvement is there. Okay, then you will improve your speed. Two things you have to improve: accuracy as well as speed. So when you solve the all model given by me, then your accuracy will be improved. Practice on your own more, so many times, then speed will improve. Speed is with you and accuracy is with me. Okay. So solve questions for better accuracy. Take questions from me for accuracy. Solve from you, then speed. Speed and accuracy, you will be winner in life. Okay. So the wavelength of radiation emitted when hydrogen atom electron proton is a station state. So whenever I read, I catch up that keywords. Here the keyword is infinity and the stationary state 1. Okay, and hydrogen. Understood? So from hydrogen, he is asking beta use it z equal to 1. Okay, and from infinity he is asking beta use n2 is equal to infinity, and from stationary state 1 he is telling these are all signal language between the examiner and the student. If you are able to understand that signal language, decode it, then you are success. Okay, now 1 upon lambda, what we want? Wavelength. So that's why 1 upon lambda. Okay. RH into 1 upon n1 square minus 1 upon n2 square into z square. Okay. Z equal to 1, n2 is equal to infinity, and n1 no root. Da, 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 da. And RH from the Bachpan, you know that 109678 units will be in centimeter inverse. Okay, so 109678 centimeter inverse. Put all of them, you will get 91 nanometer. As I got 91 nanometer, you can do it or not? Calculation also should I do? No. 1 upon lambda is equal to R0. You can convert this centimeter, but options are in nanometer. You can convert it or not. N1, how much you will put it? 1. Okay. Just reciprocal of this only. N1 is equal to 1 square n to infinity. Reciprocal of this, you are going to get 91 nanometer. Is it understood? 6 questions we have successfully completed. And we are going to do some more, 2 more questions for octet, 8 stable. Okay. Okay, next question is calculate the wave number of shortest wavelength transition in the Balmer series of atomic hydrogen. Okay. Try. Every time you will not get options. Sometimes you have to guess, you have to do it, and then guesswork will not work. Okay. So you can try. Tried? Calculate wave number. Nu bar is equal to question mark. Shortest wavelength. For shortest wavelength, what trick I told you? Don't know. Go through the video lecture. Then only will come to know. Remember, for shortest wavelength, N2 is equal to infinity. And Balmer, Lyman Balmer, N1 is equal to 2. Atomic hydrogen, Z is equal to 1. Okay. So, nu bar is equal to 1, sorry, RH into 1 upon n1 square minus 1 upon n2 square into z square. 109678. This will be in centimeter. Okay. So 1 upon n1 square 2 square minus 1 upon infinity square, z will be 1. Okay. So on simplifying, you will get a beautiful answer in centimeter inverse. You have to cross check with the options. Understood? If it is integer type, then units will be mentioned in exam. Don't worry. Okay. Some students are not even bothered to solve. They are asking, sir, tell me answer, na sir. So I have solved it for you people. So this is 27419.25 centimeter inverse. Is it understood? Now we have completed 7 questions. We are going to end this with the beautiful, wonderful 8th question. Okay. Okay. Are you ready for the final 8th question? Octa. Okay. Octet 8th question. Wavelength of high energy transition. High energy transition. High energy. Energy is highest when. So what he was is telling us, use N2 is equal to infinity of hydrogen atom. Okay. High energy transition of hydrogen atom in ground state. He has mentioned here. So N1 is equal to 1. Okay. And when this transition took place, it is 91.2 nanometer. Find corresponding lambda. That means this lambda is given. This lambda we have to find out. Okay. In of helium, that means corresponding means N2 is equal to infinity, N1 is equal to 1, and lambda is equal to how much. Okay. One thing you should also make sure that here for hydrogen Z is equal to 1, for helium Z is equal to 2. So what is given in English, I have explained and written it here. You should be able to understand it nicely. This is given, this is required. Okay. So can you do it now? Okay, try. I will do better than you, smarter than you, faster than you, accurate than you. Let's see. Right? See here. I am doing faster than you. See, N1, N2 is everything same. Don't use. Okay? Simply lambda is directly 1 upon lambda directly proportional to z square or not. Okay, from the formula. Why I am doing? Because these are all nonsense. Everything is same. We are given with lambda. We want to find out to another lambda. Z is also given. Okay. So what I will do? Helium and hydrogen. Suppose 1 upon lambda of hydrogen is equal to what I will do? Z of hydrogen whole square. And here if I write Z of helium plus whole square, here I will get lambda of helium. Is it understood? So very direct formula, shortcut technique, smart people, smart work, and easy task. Okay. So lambda of helium only we want. So just to throw it to that side, go that side. Lambda helium is equal to lambda hydrogen. Okay. So lambda hydrogen into Z of hydrogen square divided by Z of helium square. Okay. So lambda hydrogen 91.2. That everything I will erase and make it neat and clean. Okay. 91.2 into hydrogen atomic number 1 square divided by helium atomic number 2 square. So 91.2 divided by 4. 91.2 divided by 4. Is it understood? Let's see. So understood 22.8 nanometers. Any doubt? No doubt. Okay, thank you for staying with me. See you. Bye bye. Meet you with these wonderful topics, wonderful questions. Stay tuned with me. Stay with VIJ CHEM and explore your good career. Okay. So kindly share this channel to your friends who are not able to reach me in my class. They can watch it at any point of time, any number of times. Okay. And kindly make a note also. Bye bye. See you.